Hey everyone, I'm your host Tom Shaughnessy, and welcome back to Chain Reaction, a research-driven podcast that's a part of Delphi Digital. If you're not on Delphi's research portal, you're missing out on the critical analysis read by the top minds in the crypto space, so be sure to check it out. One quick housekeeping item: nothing said on this podcast is a solicitation to buy or sell any security or token, or to make any financial decisions. Hey guys, I also wanted to tell you about ZenLedger, the best tax software for cryptocurrency investors and accountants. It's fast and easy to use, and you can get all of your crypto transactions in one place so you can trade smarter and optimize your taxes. ZenLedger offers 24/7 customer support by phone, email, or chat to help you get your taxes done stress-free, and it comes with a 100% money-back guarantee because they know you'll love it. ZenLedger is giving an exclusive 15% discount to our listeners when you use coupon code CHAIN15. Go to zenledger.io, linked in the show notes below, to get started and get your taxes done fast. With that, let's jump into the episode. Hey everyone, welcome back to the podcast. Today I'm thrilled to have on Anatoly, who's the CEO of Solana. How's it going, Anatoly?
Hey, it's going great. Great to be here.
Thanks for hopping on.
For sure.
So you guys have gotten a lot of buzz, I think, most recently with Multicoin's investment in Post, and you guys, you're pretty much a brand new project in this space. I guess it's best to hear it from you. What exactly is Solana?
So, I guess people hearing about us for the first time think it's brand new, but it's a project that we've been working on for 2 years. So it's coming together. That doesn't feel as brand new to me. But what is Solana? It's a high performance blockchain. So if you want to think of like Ethereum as this world computer, we're building one that we think is the fastest one that's theoretically possible.
Yeah, that's funny. I actually interviewed Urbit the other day, and I was like, "Oh, this is brand new," and the guest is like, "No, we've been working on this since 2003." And I was like, "Oh, okay."
Yeah, yep.
It feels like that. So basically, you guys are a new blockchain, and one of the things that you guys focus a lot on is your high transactions per second, but while maintaining decentralization. I feel like a lot of people kind of have an issue with that in their head, just given all the talk on issues with past blockchains,
Yeah, so this all comes from like this whole trilemma that Vitalik Buterin came up with. I'm sure your listeners have heard of this, right? There's this constant trade-off between performance, security, and decentralization. So when we tell people, oh, like our public network that's got a bunch of validators or globally distributed can do like 50,000 transactions a second, we must be cheating somewhere, right?
Yeah, it's actually funny though. I mean, a lot of the really centralized blockchains like EOS has 21 nodes and it can't get past, a couple hundred transactions per second.
Yeah. So the thing there though, like it's kind of ridiculous that they're that slow, because this whole trilemma comes from the idea that at some theoretical limit, you hit bandwidth limits, that you simply can't move at that much memory between that much information between all the machines in the same network. So therefore, you have to split the network, and you have two networks. And because you have two networks that are at full capacity in terms of their bandwidth, they cannot synchronize their state, and therefore they cannot really come to full consensus, right? So that's where this trilemma comes from. But 100 transactions a second is like 10 kilobits, 10 kbps, right? I have 1 gigabit at my house. In our hands next year, we're all going to have 5G phones. That's globally 1 gigabit point to point between any two humans. And
yeah, it's insane.
You can fit like 1 million things per second in a 1 gigabit. So that kind of problem, I think, when people start building these like other solutions that are really trying to, from what I can tell, they're trying to solve a computer science problem. How do we build these sharded networks where we have high degree of security, but we are able to split the state and the bandwidth? And that is like a insanely hard problem. And that problem is so difficult that like you see Ethereum Foundation and all these other projects struggling to ship, concrete implementations that are robust and in the wild. We have a different thesis, and this is basically based on my background and my experience, is that just hardware is just going to keep getting faster and faster. Like when we started, we write a bunch of GPU code to do signature verifications. It took 4 GPU cards to do a million. Now you can take one 2080 Ti and just one card can do 3 million signatures per second. To achieve our like public testnet numbers, you don't even need GPUs anymore because AMD just doubled the cores again. So this is like an exponentially growing, like insanely huge and like really established industry that's just going to continue to deliver hardware that continues to double in capacity. So why fight that, right? Every 2 years, we either double capacity or we get twice as decentralized because the price of the hardware is now half as much.
Yeah, it's funny you bring it up. So you guys are basically just building off of Moore's law here. I guess the dumb question though is how exactly do you guys work with that hardware though? Is it just people running better hardware as nodes? Like where exactly do the improvements play into it here?
Yeah, so the challenge, why I think not a lot of folks stumbled into this kind of our approach, is because consensus systems, the way they're traditionally designed, have this kind of very static synchronization point. Like you look at Tendermint or EOS or these other BFD systems, or like even hot stuff, even though it's pipelined, all the machines do one thing, they compute one block, they all agree on that block, and then they move to the next one. So there's this kind of like constant source of synchronous agreement that needs to happen before the machines go do the next thing. Because of that, that means that all these computers across the entire world have to all talk to each other and communicate and send messages and come to agreement and then go do the next thing. So that kind of like the step function is like just an immense pain point to optimize. So why we don't have this problem is like comes down to our secret sauce, which is like, a marketing term for it is proof of history, because every project needs to have a proof of something, right? But underneath it is this mathematical technique called the verifiable delay function. What that means is like proof of work in Bitcoin, it is a cryptographic puzzle, but unlike proof of work where the more electricity you have, the faster you can solve this puzzle or the higher difficulty puzzle you can solve. This one requires you to spend real time. That no matter how much money or electricity you have or resources, it takes you some measurable amount of real time to solve. And that physical constant is based on the fastest possible fabrication process for a computer chip right now. So TSMC, Global Foundries, Samsung, they're about to start shipping 5 nanometer chips. That's as fast as it's going to go. For you to make it faster, you have to go build a 3 nanometer fab, and that's like $40 billion. So, and your speed up is going to be roughly like 20%. So within that bound, we have this problem that takes real time to solve, and it's very expensive for somebody to make it marginally faster. We can take this data structure and construct a clock, a source of time. So imagine like a water clock, but instead of water that's dripping and the levels rising, you kind of have this data that's being accumulated, and that data represents the passage of time. So once you have a clock, you actually get a big pile of distributed systems optimization techniques that have been around since since radio, since like early 19th century.
Got it. So a lot to unpack there, and I like the timing aspect. I guess, how do you think about like what's the other definition of proof of history though? Like, so you guys have a global. Is there a global clock, or are all the nodes computing time themselves? I'm just wondering how that works.
It's global because every node can recompute it and they can verify it, but there isn't like a single machine that's running this. So it's global because that information is available everywhere at the same time and doesn't require communication for us to agree on it. So, like here's an example. Like, so Google has this database called Spanner. It's globally distributed database, and each data center that they run, they actually have an atomic clock that their engineers synchronized. So internally, that thing uses like a cesium atom, right? And it's like moving at some physically bound speed, and they can compute the time. And because their engineers synchronize it, they can trust it. And none of those clocks have to communicate with each other, right? That information about time passing is the same everywhere. It's bound by the physical constants of the universe, right? So in that similar way, right, even though it's not like a single clock, right, they have 10 data centers, they have 10 clocks, that global source of time exists for the entire network.
Anatoly, I really like the flex, though. I mean, basically, hey Google, we solved what you're doing in massive data centers by rerunning a hash function.
Exactly. Our very clever, like, we're not actually even the first ones to think of it. Right around that time in 2017, when I started looking into this, Intel published this thing called POET, which is proof of elapsed time, which leveraged their secure enclave. So if you trusted Intel and you thought that the secure enclave was secure, which is not, then you could use POET to kind of construct similar proofs. Where our kind of real innovation is being able to do this in this trust minimizing, pure mathematical way. So that's kind of the neat trick here, that we're able to just take math and construct a source of time with it. If you want to get into philosophy, there's some really interesting things about that. So we can definitely can go in that direction as well.
No, I definitely want to. I just want to make sure I totally understand it. So basically, what you're saying is that current blockchains all have to agree on transaction ordering, and it leads to, basically a slow network. What you guys have is every node could run time by themselves so that they could timestamp messages, so they could have high TPS, but they don't all have to be in contact with each other.
Yeah. So the problem comes down to like ordering block producers. Like proof of work, right, is this puzzle and this design. So whatever the current hash power in the network is, it takes roughly 10 minutes to solve it. So that means that on average, every 10 minutes, there's a single block producer that produces this block and transports it. So the number of collisions that's expected is quite low. It's pretty rare, even though it happens occasionally, that two block producers produce a block at the same time, right? And the network sees a fork and has to pick one or the other. If you reduce the difficulty of that puzzle, like Ethereum did, to 15 seconds, then you get these things called uncles, which are much more frequent forks. And Ethereum does some clever optimizations to kind of not waste the forks, not waste the uncles like hash power. But at the end of the day, it doesn't allow you to produce more blocks and more transactions per second. Radio towers had the same problem, but they kind of went a different way. So, imagine first radio network. We put up two towers and they transmit at the same time over the same frequency. Radio is an electromagnetic wave. Those waves, as they propagate, they interfere with each other, and that interference creates noise, and therefore information can't be sent. Right. So that problem becomes worse and worse the more radio towers you add. So if you have two towers, right, and they both randomly transmit whenever they want to, you may have few collisions. But if you have 100, all of a sudden everybody's talking over each other. So the first thing that people thought of was, why don't we give everybody a synchronized clock and they alternate? So everybody transmits at a different second, right? So you figure out when you're assigned, which seconds you're assigned, and then you can only transmit during that second. And if you violate those rules, the FCC goes and smashes down your tower, right? So that's basically how it works. Now cellular networks, you have like a million devices all connected to a single 4G tower. They're all synchronized within 5 milliseconds. Uh, so it's gotten much faster. And because of that, right, the lower the error you can get, the more concurrent participants you can have. That means the more blocks, right, in essence, this network can generate. So we have a clock that's, by clock standards, it's a crappy clock because it has this kind of high variability between what it thinks one amount of time is, one unit of time is. But it's a clock that is completely trustless. There isn't like a single synchronizer. There isn't like a global trusted network like tower that you have to trust, or we don't have to like even trust GPS or anything like that. So it's solely based on this cryptographic puzzle, which is SHA-256 that recursively loops over itself. And that in itself allows us to stagger when block producers produce their blocks. So because they're forced to solve this puzzle and the difficulty for each one is different, takes them different amount of time, so they never collide. Or when they do collide, it's rare, and we can deal with that with those collisions using consensus. So that's basically the trick, and that trick allows us to like improve, which I think the hardest thing in any of these systems, it's not TPS, it's latency. It's how fast does a transaction get encoded into a block and the network agrees on that block. So right now for us, it's like 400 milliseconds. And this is global network, validators in China and Korea and Singapore and Europe and North America, South America, Africa even. I think there's a node in Australia. If you look at like the map, it's literally a global computer that's synchronized within 400 milliseconds. That's pretty cool, I think.
No, that's really cool. And I really like the explanation on time and on the wireless comparisons. It makes it a lot easier to understand. I guess the other naive question for you is, Bitcoin and Ethereum, everyone talks about security, the cost to mine, social consensus, all of these things that feed into security. What's the security underpinning you guys? I know you said time and it gets really expensive to basically run the script faster, but is there a way somebody could hack this? Like if somebody gets a better chip faster from, Intel or something like that?
So for that aspect of it, you can be a block producer more often than you're supposed to, but you have to reveal that you have this faster chip. And that in effect is problematic for proof of stake networks because stakes are kind of like, so underneath, right? Proof of history, it's just a source of time. It's not a consensus mechanism. It doesn't allow us to come to like an agreement, like Byzantine fault tolerant agreement, like where we have M-Van agreement between the network. So some Sybil resistant mechanism is necessary, and for us, that's stake. If you reveal that you're a faster block producer, you may be able to generate more blocks than you're supposed to, but it's not like an attack that will stop the network. So in that sense, from a user's perspective, they may actually see better performance. From a validator's perspective, they may see a validator that's producing more blocks than they're supposed to.
No, that's fair. And Anatoly, this might be a question that drives you crazy, but you guys are obviously focused on, scaling without sharding, and there is, for lack of a better word, a tsunami of developers focused on sharding layer one blockchains. Take your pick on the smart people in the room. Why are they spending so much time on this if it's, kind of a solution you guys have solved? Like I'm just like there's clearly a disconnect in where people are spending their time.
Yeah, so I think this is probably my background. Like I spent most of my career at Qualcomm, which is maybe a company that not a lot of folks have heard of, but they're kind of the Intel of the mobile industry. So I spent like 12 years literally working on optimizations, making all of this like cellular radio and like operating system stuff go as fast as possible. So when I realized blockchain has a scaling problem, I went to what I know, right? Which is this is how we scale. This is how we scale like networks, to billions of people globally. So why don't we do the same thing here?
It's
I,
like,
I
hey guys,
think
we already have a solution here.
the sharding part I think comes from it's like a really tough computer science problem. So a lot of the folks I think that are coming into the space building these scaling solutions are more academia background, and maybe that's where it's coming from. At the same time, I don't think we've seen a lot of sharded solutions shipped. So Zilliqa is one, and they don't actually shard state. So they've avoided the kind of the hard problem. That's why it works.
No, that's funny. I mean, the other question though is, do you really think that sharding on other layer ones won't work? Like, do you think Ethereum 2.0 just straight up won't ship?
No, it'll ship. Like it'll ship with caveats, right? Like maybe it's gonna be not like 1,000 shards, it'll be like 64, 32. Maybe maybe it'll be slower than Ethereum one in any single shard, right? So there might be a lot of kinks to work out. But at the end of the day, I think that system, right, that's built is going to be worse than a really, really fast single shard that doesn't have these like that's super low latency.
No, that's fair.
Right. So for developers, right? Developers that have users, like from what we have seen, there are more companies that have kind of Web2 user bases that they're experimenting with crypto. Instead of there's like a real business plan here that you can take your Web2 ecosystem that has a bunch of users, and instead of stealing the users' data and selling it for ads, you can introduce some crypto economics and have those users create better content, right? Better social networks, and just through the transaction flow, earn money to pay for all the servers and all the engineers. And that is like I think a super interesting model right now because it's the content is better because it's not advertisement, and the users are better, have a better time because their data is not being stolen, right?
Yeah.
and like and all you're doing is like introducing like a way for the users to monetize their social graph, their relationship themselves, as well as like this network itself. To me, like those kinds of like ecosystems are ripe for adoption. And those systems can't really work on sharded chains because, let's say you have 1 million monthly active users, how are you going to split them into shards, right? Like if you split them in two and half of the interactions now have to go through cross shard communication and like do this big synchronization step, you're not talking about like even waiting for, like 90 seconds on Ethereum or an hour for 6 confirmations, right? Like it becomes like a very, very not fun development environment.
Hey guys, I also wanted to tell you about ZenLedger, the best tax software for cryptocurrency investors and accountants. It's fast and easy to use, and you can get all of your crypto transactions in one place so you can trade smarter and optimize your taxes. ZenLedger offers 24/7 customer support by phone, email, or chat to help you get your taxes done stress-free, and it comes with a 100% money-back guarantee because they know you'll love it. ZenLedger is giving an exclusive 15% discount to our listeners when you use coupon code CHAIN15. Go to zenledger.io, linked in the show notes below, to get started and get your taxes done fast. No, I understand the point. I guess the question I would push back on, I guess, is, let's say that you guys have better tech than Ethereum 2.0. Like, let's just say for argument's sake, just for the sake of the question, let's say you guys have better tech, but Ethereum has arguably has all the dApps, all the current devs, Web3 guys. Like, there's just so much going on there on the dev side. And I feel like, they'll make it work. Like, do you view their developer moat kind of like as a moat, or how do you view that?
Developers don't have moats. Like I'm an engineer. Like I'm not. I use the best tools for the job, right? Like it's not like I care whether I use Postgres or MySQL or whatever. You just if you actually have a real problem to solve, you use the best tool for the job. Reality is that like you look at data that DApp Radar published, there's what 20,000 daily active users between all the dApps together, and a large chunk of those top used dApps were not like very like cool, right? There were Ponzi schemes. So
Yeah, I guess the other, like, how would you think about, though, like other moats? Like liquidity is a big moat, like Uniswap or something like MakerDAO. Like there is kind of like winner takes all or winner takes most kind of moats here that kind of go beyond developers, right?
that is, I think, is like a really interesting and cool phenomenon. And I'm not sure if Ethereum has a moat there, but they definitely have a resource that's very hard for anyone else to replicate. But at the same time, like you look at Tezos and Cosmos, totally different blockchains, right? Both are now worth over like near 1 billion something in market cap. Does Ethereum's 10, 20 billion market cap present such a huge moat versus Cosmos or Tezos? Like I don't know, right? But like to me, it seems like there's some diminishing returns there, and I don't know how value is going to be captured, but like I think again, the way I look at the space and what we're doing is, it's Internet 1996. I may even believe that in 1996, imagine if somebody told you that, hey, you know what? We're going to the internet's going to become 3 billion people, and we're just going to connect them and get them to share pictures of their cats. And that's going to be worth $500 billion.
Probably would have laughed at the time.
Right? Like, you're like, no, the internet's going to be used for like real communication and businesses and all this other shit, right? Like, reality is that nobody knows what the killer application is that's going to capture the most value. Right now, we're doing a bunch of experiments. I believe it's DeFi as well, like everybody else, but I think DeFi needs like hundreds of millions of users for real value to start accruing. The only networks that are going to get those hundreds of millions of users, I think, are going to be built like ours, where you have highest possible capacity for like, and lowest possible latency. So you can actually handle like, even with 1 million monthly active users, you run a promotion and 10,000 of them hit the same button at the same time, your shard is going to fall over, right? That's kind of like the problem with all these other designs. I don't think they're building for this like end state where we have a global single world computer that everybody's using.
No, it's a pretty basic example you bring up that would actually be really hard to do right now.
Yeah.
It's funny you bring it up, but I guess the other question for you there is, and it's interesting to get your thoughts on this. A lot of other layer one teams in the space, when I interview them, they come on and they say, hey, we're not interested in Ethereum's developers. We're interested in, the world's developers. And, I always take an issue with that because you really have to dominate a niche and like prove your product market fit before you have, millions of developers or something come on your platform and use your tooling. What's your take there? Like, do you think you have to win over other chains, or do you think you have to like attract outside devs? I know we're still early. I agree with you, but I'm just kind of wondering on that competition aspect there.
I guess I've always, it's probably again my failure as like, I can't imagine us building like I guess I don't believe that there's this whole idea of B2D, right? Businesses for developers, like where we can court developers and they will somehow do something useful. I always think of it as like B2B, right? There's businesses that have an opportunity, they need to go execute on it. How do we help them? If there is no opportunity, it doesn't matter what we do. So for us, we're more looking for like projects, ideas, and that could be a single developer that wants to build something out like an MVP and try to start from there, or already an established company that's doing something with crypto that may have started in Ethereum is now using some random chain internally. So for us, it doesn't matter. We actually have to give them something that they can't get anywhere else, right? Or help them somehow. This is how I kind of frame it in my mind. And the way that we are able to like sell Solana is that, look, if you're using blockchain already, we don't have to sell you on the idea of using blockchain, but here's a much faster, cheaper one. Now, a lot of use cases, that doesn't matter, right? If you're doing like real estate transfers, something like that, nobody cares. You don't need Solana for that. But we have a partner with like over 1 million monthly active users, is going 20-30% every month. That's who we're onboarding, and they have a burning need for faster and cheaper. So that's kind of my ideal outcome. If developers have like an actual need, right, they'll come to us. I think Ethereum has had success because of the kind of where they came from. They were the first real like platform for people to build anything. So they have first mover advantage. The people that did start early made a lot of money in the kind of in ETH itself, and they absolutely have no desire to leave. Right? Like if I have a bunch of ETH and I made a lot of money, why would I try to build on anything else? But at the same time, if they have a runaway success, right, have a bunch of users, and all of a sudden it becomes a business problem that Ethereum is too slow and too expensive, then that's kind of a very clear, simple decision.
No, that's fair. The framing, I guess, is understandable. And I mean, I'm not going to lie, your investors clearly agree. I mean, you guys raised 20 million back in, I believe, late July, I think.
So that was all together that we raised from our seed round till end of July. It's in about 3 rounds, if you think of it that way.
No, I mean it was a calm summer on the fundraising front. I feel like that's pretty solid.
But we haven't, we're not like a team that raised hundreds of millions of dollars. Like I think we are just very blessed for a Silicon Valley startup, but we're not like, runaway crypto rich, right? We're just a startup that is executing, that has enough funding to accomplish what it set out to.
Yeah, well, it's funny. I mean, not to name names, but I can. I mean, the teams that raised at billion-dollar valuations like Definity are nowhere, and the teams that raised, sub 50, sub 100, you guys, Blockstack, Near, take your pick, and see my full disclosures in the show notes, are actually executing. So it's kind of like a weird trade-off between funds raised and progress.
Yeah, I think we see a runway that is diminishing, right? in real human measurable time, and we're like, we need to execute and ship now. While if you raise $100 million and you have like a normal sized engineering team building this stuff, you may never need to ship, right?
Yeah, they literally have no incentive to get to work. But back to your earlier point, one of the things you brought up I thought was super interesting is that you guys aren't fighting Moore's law here. You're basically using it to your advantage. So the better hardware that comes out, the better your network gets. So basically, you guys don't need like layer two tech to grow your throughput here. You just need AMD and Intel to keep basically taking advantage of Moore's law and shipping better hardware.
Yeah. So Moore's law, people understand it. People say, is Moore's law dead? What they typically talk about is clock speeds. Like we haven't seen clock speeds over like 3.5 gigahertz commercially for a long time. But what does continue to happen is the number of cores, and especially cores in GPUs that don't have to synchronize on cache, those keep doubling like every 2 years, like clockwork. So if you build software that is like designed for hyperparallelism, you can take advantage of it. And every 2 years, we can either double the amount of capacity this network has for for the same cost, or reduce the price for every validator by half, right? And therefore, when people say Solana, like, are the validators too expensive? Our validators are the same ones that are running all the other networks, and they're all running Solana on the same soft hardware as all the other networks. Because when you go out and buy hardware, you just get the standard set. You don't go buy Raspberry Pis if you're running like a bunch of validators, right? So we're just able to leverage them a little better.
No, that's fair. And I guess the other kind of question down this line is that there's a lot of misconceptions about you guys out there, and I know we discussed a few offline, but I'd love to hear from you. What do you think what do you think are some of the top misconceptions about Solana or about what you guys are building?
Probably like one you mentioned is like, people think when I say global clock, they think there's some single node that's running a clock. So that's one. There isn't a single node that's running a clock. It is a virtual clock that's globally available everywhere because everybody can recompute it. So it's kind of mathematical construct. The other one is that, like, because we always talk about how hardware helps us scale, people think that validators are going to be too expensive to run, or like they imagine data centers that are synchronized. Reality is that like a single computer these days, or like even your phone, has over 1,000 cores in their GPUs. So that thing, like my phone, could probably handle 1 million signatures per second. The rest is just bandwidth. So it's not that we are it's not like we're taking absurd amounts of hardware and scaling blockchain. It's that we're wrote software that doesn't suck and is able to use the hardware that's there. uh, we recently had a developer take a $5 droplet and get over 1,000 TPS on our in our little bench test. So that's like the cool thing there, though, and this is like the really cool thing, is you can deploy this 1,000 TPS droplet for $5 a month, and that's probably where you're going to see steady state, right? Like we're unlikely, even with our partners that have like over 1 million monthly active users, actually see steady state, more than a few hundred transactions per second. But what's cool is if there is a huge spike, that $5 droplet could just fail over to AWS, to whatever, to a much bigger machine for the 10 minutes that there's a lot of demand, and process that data there and then come back down to this like low cost device. So just because we say like, hey, we're scaling with hardware, people don't realize that hardware is very elastic. You only need to pay for what you're using at demand. And that's kind of a really, really cool thing.
Yeah, it's like the AWS playbook, basically.
Exactly.
So, just on progress and kind of your roadmap here, where are you guys on your path? Do you guys have your mainnet out? Just wondering, kind of progress.
It's literally like we just had like yesterday we got everybody together and decided if we're gonna do a go or no go for launch. And I think it's a go. We seem to have kind of all our fires under control. And we think we'll do like a dress rehearsal launch end of the month, and then a week later the mainnet. So caveat: what is mainnet? So we think mainnet like it's kind of like mainnet beta, where we feel pretty good that there aren't any exploits or bugs that could break consistency. But it's a network that we wrote with a lot of sleepless nights. Literally, like the first line of code was 2 years ago. We've been trying to ship this thing as fast as possible. So we want to make caveat it that like, look, this is MVP software as best as we could. So availability might be the thing that could suffer. And I think in 6 months we'll see if we actually have bugs that are like would bring the network down for an hour or two, or did we actually do a pretty good job in finding all of them? As far as we can tell, there's no main big issues, but we want developers to understand like, hey, first week of the network, it's the first week of the network.
No, it's always a fun time, and I can't imagine how much sleep you probably have to catch up on. I guess the other question is, how did everything go with your test nets and stuff like that? Because if you guys are this close to a main net, they must have they're obviously closed now.
Oh man, yeah. So I mean, we started trying to onboard validators last summer, and just everything you could possibly think of going wrong went wrong. uh, just even going from like getting validators to run nodes on Google Cloud with us to open internet, just a lot of weird edge case assumptions that we made about how data is going to propagate. We're all wrong. We had to like rewrite the network stack and optimize it, and getting like these operational issues like validators accidentally reusing private keys between testnets, stuff like that. A bunch of small things that cause a lot of weird errors. Fixing all of those took a while, and it is kind of like coordinating cats, but it's a it's a cool process because the folks that do run the software that are validators, they're like the core community now. They've been with us from like the days that things barely worked to now where they seem pretty stable. So it's been a really cool, fun experience from that perspective.
No, I mean you want to find all those bugs, before you go live, right?
Yeah, of course.
So, Anatoly, another question for you. I mean, you guys have a lot of tech. I mean, we talked a lot about proof of history, but there's like a laundry list here. Tower BFT is your basically your consensus mechanism. You have Turbine for block propagation, Gulfstream for meme poolless transaction forwarding, Pipeline VM, Cloud Break, replicators. I'll link to this in the show notes and let everybody look through what all of these are, but I'd rather just talk about them in aggregate. Every layer one I talk to is, still building out their tech. It seems like you guys have been able to, create this entire working stack in 2 years. Like, why aren't people talking about this more?
Engineers love like building stuff. There's a lot of like even within a single large company, there's this like thing called not invented here. So it's this phenomenon that engineers want to go solve the hardest problem because maybe that's what they taught. You spent like 4 to 8 years in school learning how to solve these computer science problems. When you see one, you want to go try stuff out, right? So I don't know, like, why wouldn't Ethereum 2.0 use like code that Near built, even though the designs are very similar, and vice versa? That to me is, I think, like a social phenomenon. you also like you look at anyone else's code, and it's very rarely that you don't see like some reason not to use it. And I think what we'll see actually is the projects that'll succeed the most are the ones that can cannibalize everybody else. That can actually lift pieces out and start integrating them as fast as possible.
Yeah, no, I definitely am one to believe in the winner take most in the layer one side. That's why I've always, had an issue with interoperability protocols, to be honest, just mentally. But I don't know. I guess we'll see.
I've thought like that as well, but now I'm not 100% certain. Like I don't know if there is like a single chain to rule them all, because the security assumptions between all of them are so different.
Yeah, that's fair. I definitely don't think we'll land on one. I definitely think there'll be a few. I just, some people have these visions where everyone will have their own blockchain, or there'll be thousands, and I'm like, it just seems like so much work, you know?
Well, do you think that like if like Libra succeeds, do you think that Fortune 500s in the US will launch their own blockchains, or will they use Libra? Or will they use a public one?
Yeah, it's a good question. It's a really good question. I mean, to be honest, I think that's why some of them backed out of Libra. It's just because they saw the competition there, and maybe they don't want to go up against it, or maybe they want to run their own chain. Definitely could make sense.
Right. I mean, like if Libra starts getting traction, and like it didn't make any sense to me that Visa and Mastercard would be using it because they have their own networks. Like they're basically like would let Facebook cannibalize their user base from inside out.
Yeah, whoever was doing the sales at Facebook to sell that to them, I applaud them because they got them through the door before they figured it out.
Yeah, yeah, exactly.
Yeah.
Yeah.
And Anatoly, you talked a lot about a partner you may have. We didn't talk a lot about it, but you mentioned it. I'd love to hear your thoughts on kind of use cases for Solana. Where you see kind of people using you guys out the gate. Do you have people waiting for your mainnet to go live? I'd love to kind of discuss use cases there.
Yeah, we've been like I guess focusing more on the B2B side. We do have an accelerator program that's open to developers as well, and r- would love to see more folks apply and building stuff that really requires a high performance chain. The kind of use cases that I imagine that I would love people to experiment with is more on the kind of near high frequency trading side. So like the first pitch deck for Solana was like, okay, what are the main use cases? Well, we have a high performance blockchain. It is, I think, by definition, of engine of price discovery. So, like stuff like that flash loan hack, I think, is like the perfect culmination of what a blockchain should be. It's a state machine where you have a lot of crazy financial instruments, and bots should be trying to exploit them like as fast as possible. And if we have the fastest version of that, then it should have the most fairest open prices to anybody globally. Um, so we actually built like a little matching engine that can do about 30,000 price updates per second. So I think at that speed and performance, you can start doing interesting things. And I would love to see people try that. Like even things like where you have a bunch of validators, they're all block producers, they should be running like arbitrage bots to figure out which transactions can exploit the current state. And by exploit, I mean like remove arbitrage and create a fair price, right, for everybody else. So that stuff, I think, to me would be fascinating. I'd love to see folks experiment there. Where we have traction with like other projects that have reached out to us is things like micropayments, because you can't really do micropayments in Ethereum on anything else really. You need for the web, you need low latency, and that's really where we have an advantage. We haven't, again, probably because of the team's background. So myself and a bunch of the folks who are like former Qualcomm engineers. There's an interesting challenge in like 5G, especially the rollout in the United States. These towers, that we've talked about, like 4G towers have a range of 30 miles. 5G towers are about 500 feet. So the density that you imagine, like for like cellular towers that are going to cover coast to coast is orders of magnitude higher. And it becomes like a real-time billing problem. Because as you're driving, you're switching different operators and you're continuously using multiple towers, multiple quality of service, multiple data streams, and everybody needs to get like appropriately billed for that.
Yeah, it's a really interesting point you bring up. I used to be on the telecom and cloud team on the equity research side on Oppenheimer, and we used to dive into 5G, and it was such an engineering hurdle a couple of years ago when it was first talked about because if it was raining, the signal wouldn't travel. You needed massive MIMO, you needed backhaul, you needed to adjust the spectrum. You could only use, and then they had the spectrum auctions for billions of dollars just to use different levels of spectrum. It just seemed like such an issue. So when I see, T-Mobile, Verizon, AT&T advertise 5G today, I mean, I know it's fake, but
yeah, it's a joke.
yeah, yeah, there's no way you're getting multi gigabit speeds with low latency on, a first 5G network.
Yeah.
So, I mean, it seems to me though that developers should be moving to you guys if it's there, right? Like something like a decentralized exchange where there's real issues with delays in confirmation times. It seems like something like that on the DeFi side would make a lot of sense on Solana. Do you think that you'll be able to attract the DeFi use cases that need high throughput? I mean, I keep going back to this idea that you have to break the community to do it, but I'm just wondering what you think.
Again, like it's infra, right? Infra in itself does not like we have a like. Do you know the folks at DDEX? It's an awesome group like that's out in China that run like a decentralized exchange in Ethereum. We've been close friends with them for a long time, and kind of product we're experimenting with is like doing some form of high frequency trading that they could expose to their customers. That part in itself, the fact that it's faster, isn't what users really care about unless it translates into them having a better experience, which it will a bit because their trades can clear and execute faster or take more risk on the trading side, right? So where that matters is because it's higher frequency, right, or faster block times, the spreads and the latencies and settlement are much lower. So you can actually expose higher risk products, higher margin products to their users. And so there's opportunity there. But the key part to success there isn't, I think, on the infrastructure side, it's on the user side, attracting more real users that want to use this stuff, not for the tech's sake, but just for the actual usage sake. Um, and as a layer one, right, like we're not a B2C company. We're not selling something that my parents would use. Like we're like a high performant, like synchronized chip, but the global chip, right? So almost more like hardware, maybe more like a database. But like, I don't know how the expectations that people have that layer ones are going to bring about like the era of blockchain, I think is misplaced. It's going to be more on like companies and that have users or individual developers that can experiment and build something cool that catches fire.
No, I like the framing. It's fair. I don't expect my parents to ever really use this stuff, to be honest, at least not now or anytime soon. The other thing I'd love to talk about, obviously not a recommendation, but I just like to know how it interacts with your platform. How exactly does the Sol token work within your network? Is this something used by validators, by stakeholders, Visa payment? Like, what is it used for?
Yeah, there's only one token. It's the Sybil resistant mechanism for voting. It's also burned for transaction fees and for state rent. So it isn't in itself kind of like in like an operating system term, it's like the file descriptor in the kernel. It's a kernel resource. You need more of them to do more stuff, right? To use more cycles when you execute a program or to vote with larger weight. So
No, that's fair. I'll link to it in the show notes to your white paper as well for people who want more info there. And Anatoly, I know we're wrapping up, but I'd be remiss if we didn't get into this philosophy idea you brought up in the beginning because I'm interested and I wrote it down. What's your philosophical take on time, or I might be misremembering what you said?
yeah, there is like this really interesting observation that mathematical constructs typically have some smallest physical representation, right? So like imagine I took multiplication of two numbers and I arranged atoms to basically do the multiplication, like the smallest possible set of atoms. And that algorithm is physically run through the atoms and you see the result. Like so at that level, right, you can kind of imagine computers as being some form of this, but much less, much further away from the smallest possible implementation of anything, right? But we don't have this representation for time. Like there's a physical process for time, but we don't even have a mathematical explanation for it. That what is time, right? So you can think of SHA-256 as this kind of magical function that takes data and transforms it in such a way that information is lost and cannot be reversed. And if you run it over and over again, that sequential process is almost like a mathematical representation of time. It literally is like like an algorithm for time, a physical thing that we experience on a day-to-day basis, right? This this approach to building that construct could be like how time is actually constructed, right? And it's kind of mind-blowing to think about it that way.
Yeah, you're throwing me for a twist here because once you start to think about it, you really go in circles with this one, and a lot of people really don't like to talk about it.
Yeah. There's a. I mean, it's kind of related to this like famous problem, Paulo P versus MP. The fact that there is this set of problems in math that are that we have no guarantees that they can be executed or they can be solved very quickly. Kind of like the Bitcoin puzzle, right? We have no real guarantees that there isn't some magical quantum machine that can solve that puzzle in like instant time. But we also don't have a proof that it's impossible to do that or that will ever be possible. And there's the idea that we may live in like a universe that is designed. It's our mathematical properties of our universe are such that it's impossible to construct even a proof whether there is a fast implementation of any of these things or there isn't. Like we may never know, right? And that's like a really cool thing to think about. To me, like on like a spiritual level, it implies that if we live in a simulation, it is so sophisticated that it might as well be like beyond us, right?
Yeah, no, I'm glad we're down this rabbit hole. I'm just thinking through to like all the sci-fi movies I've seen and the Matrix and everything here. What do you personally think? You think we're in a simulation?
Like I said, I think if we live in a simulation, it is so sophisticated that the machine is simulating us is effectively godlike, right? It's beyond our understanding.
No, I definitely agree with beyond our comprehension. I'm just wondering, whether that machine is then in its own, world and it just goes on and on above its comprehension.
Well, that means we understand it, right?
Hey, look, let's just be happy about the new clock you guys have, all right? Let's be happy with proof of history here.
Yeah, down for that.
Anatoly, absolute pleasure having you on. Very chill episode. Learned a lot. I appreciate episodes like this. It was fun. Where could people follow you and learn more about Solana?
We have a Twitter. We have a Solana.com website. It's a very active GitHub. If you're actually interested in working on a layer one, we would love folks to just jump in and work on the core code. I mean, a lot of people talk about focus on developer adoption and all this other stuff, but I think it's critical for decentralization to actually have a project that's being built by a large group of people outside of the core team. So we're looking for folks that just kind of love working on these hard problems.
No, I definitely think that's valuable. You need that global base of different minds and different people. All the links Anatoly mentioned will be in the show notes below. You guys could scroll down, check out their site, blog posts, Twitter, and I'll link to their GitHub as well. Anatoly, thanks again for the awesome episode and your time.
Likewise, thank you so much.
Hey everyone, thanks for listening to the podcast. If you enjoyed it, please support the show by hitting subscribe on iTunes, writing a review, or sharing this episode on Twitter and LinkedIn. And stay tuned for our next episode out soon.